Hi guys, I welcome you all to my channel CS Lectures. So in this session we are going to discuss about a very important topic of data structures, that is BFS and DFS. So in this topic you are having a maximum chances for getting questions in any type of examination point of view, right? So shall we jump into the topic? Okay. So what is DFS? So DFS is a traversal technique for traversing any type of vertices that are present in a graph. How we are going to visit a vertex in a graph is being given by DFS, and another type is for traversing is breadth first search. So this is also one of the technique where we are going to implement it in visiting different types of vertices in graph implementation, right? So DFS is depth first search and BFS is breadth first search. Okay, so if you are going to use depth first search, we are going to traverse the vertices in a graph and we are going to store those vertices by using stack data structure. Okay, suppose if you are going to use breadth first search, okay, we are going to use queue implementation, that is queue data structure for storing the elements or the vertices of a graph in this type of a data structure, right? So next is the another name for breadth first search is level order traversal. Okay, so the other name for BFS is level order traversal. So what is a DFS? So I told DFS is a depth first search. So what is a depth? So depth is we are going to traverse the graph in depth order. Okay, we are going to move in a deeper manner, that is we are going to move in a dense manner for traversing the vertices from any of the vertex that is being given. Okay, it is not needed that we must have to use only the root node or the vertex which they have mentioned for traversing. We can use any vertex as the initial point to continue your traversing both in DFS and BFS, right? So there is no limitation or there is no condition that you must have to start only from this vertex. Okay, so while explaining these two things you will be able to have a clear idea, friends, right? So now we are going to discuss each and every topic in a deeper manner, right? So shall we proceed? Then these are all the important points which they may ask in multiple choice question, that is depth is using stack data structure and breadth first search is using queue data structure, and the another name for breadth first search is level order traversal. Okay, so please you just have a note of all these important points, friends, right? So now we will go for its detailed explanation. So friends, this is a simple example of a breadth first search technique. So I have given you a graph structure. So in this graph structure, we are going to implement breadth first search. So what is the function of a breadth first search is, it uses queue implementation. Okay, so it is using queue data structure for storing all the elements that it has visited. Okay, so what is a queue? So queue is nothing but it uses a concept of first in first out method. So friends, already I have given the videos of queue data structures and stack data structures. Suppose if you are all new to my videos, you please go and watch all the previous videos so that you will be having a clear idea of what is queue data structure and what is stack data structure. Okay, shall we proceed? Right. So it is going to use first in first out method for storing all the visited vertices of this graph. Okay, another important point which I want to tell is that BFS and DFS both can use a directed as well as an undirected graph for implementing these concepts. Okay, so what is a directed graph? So directed graph is going to have the actual direction through which we must have to use the move. Okay, so it is something it will be having like this arrow marks. So you must have to move only from here to here. You should not take the reverse direction. So that is called as a directed graph. So in that case we will be using in degree, out degree for finding the adjacent vertices. Okay friends, so before implementing the problem solving technique, I must have to tell you some of the steps what we are going to use it in breadth first search. Okay, so the first thing already I told, we can start from any vertex, right? We can start from any vertex for traversal. Okay, suppose in the question if they have asked that you should have to start from this vertex 8 or you should have to start from this vertex 1, at that case you start from whatever vertex that they have given in the problem. Suppose if they haven't mentioned anything, you can start from any vertex. So that is the first step. Okay. So once you have started from any one of the vertex, you must have to find the next step as the number of adjacent vertex that are present with the starting vertex. Okay. For example, if I am going to start from 2, so the adjacent vertex that are present are, there is a direct adjacent vertex that are present are 5 and 8. So what is an adjacent vertex? That is from 2 we are having 2 paths to move from 2 to 5 or 2 to 8. So from 2 to 1 we don't have any path, so I cannot take it as an adjacent vertex. So you can take only 5 and 8, right? So you can take the adjacent vertex as the next step. So once you have found, you are going to add all those vertex inside the queue. Okay, then we are going to display it. So that process we are going to see it in sequence. Okay, select a node, find its adjacent vertex, add it in the queue and display. So this we are going to consecutively repeat until all the vertices that are present in a graph has been visited. Okay friends, so shall we proceed for problem solving? Right. So friends, now we are going to draw a queue structure. Okay, we are going to use a queue data structure for inserting the elements and we are going to display it in the result. Okay, we are going to show it as an output. So now shall we proceed? So in this case, now I am going to take 2 as my first vertex because the initial vertex has not been given. So take 2. Okay, so what you should have to do? Add it in the queue. So this is a queue data structure. I am adding it inside the queue data structure. So queue is being added now. So now this is being visited, isn't it? So now then another thing friends, you should have to remember, once if you have added it inside the queue, it means that that vertex has been visited. Okay, so put a dash mark. So now find what are all the adjacent vertex that are present with respect to that of 2. So the vertex that are present are 5 and 8. So you can write as 5 and 8 or you can write as 8 or 5. You can use any order. Okay. See, I can write inside the queue as 5 and 8 or I can write as 8 and 5. So write as 5 and 8. So these are all the 2 vertex that are adjacent to 2. Okay friends. So now we can remove off this element because there is no need, isn't it? So I have added the adjacent element of 2. So you didn't want to mention here. So you delete it from the queue structure. So you can print here. Okay, so delete the element which has been returned with the adjacent elements inside the queue data structure and write it in the output. Okay friends, are you all clear? So now we can go for the next one. So in the queue you should have to take in first in first out order, isn't it? So the next first element is 5. Okay, so the next first element is 5. So now find what are all the elements that are adjacent to 5. So what are all the elements that are adjacent to 5? Okay, so the elements which are adjacent to 5 are 10 and 15. So 10 and 15 are the adjacent elements. So you can write as 10 and 15 or you can write as 15 or 10, isn't it? So now I am writing it as 10 and 15. Okay, so now I have added the elements that are present inside, that are present adjacent to 5. So you can delete it and put it in the output. Are you clear? So once you have added the adjacent elements, I am taking its upper node. Okay, so 5 is being taken as your output. So now What is the next element? Next first element. So the next first element is 8. Okay, so now once again you should have to find the elements which are adjacent to 8. Okay friends, so this is a deleted element, isn't it? So meaning is we have visited. Okay, see whatever elements we are deleting it from the queue, it means that it has been visited, so I am cancelling it. Right, so now write the elements which are adjacent to 8. So let me draw here. 2, 5, deleted, so 8, 10 and then 50. Okay friends, so the elements which are adjacent to 8 are, what are all the elements that are adjacent to 8? So it is 16 and 1. So the two elements that are adjacent to 8 are 16 and 1. So write here 16 and 1. I have added. So there is no necessity of keeping the element inside the queue. Just remove it and put it in the output. Friends, are you all clear? So like this only you should have to do. So now 16 and 1 I have added. So now take the next front element. So it is nothing but 10. Okay, so the next front element is 10. Now you add the element which is adjacent to 10. So you find the elements which are adjacent to 10. So 15 is adjacent and 5 is adjacent, isn't it? So 15 is already entered. So there is no need of entering it again. Okay, so 5 is visited. So again no need. Okay, so now you just don't want to enter any element. So delete it and print. Okay friends, so delete it and print, that's all. So now you take the next front element. So the next front element is 50, isn't it? So now once again you find the adjacent element of 15. So what is adjacent element of 15? So adjacent element of 15 is 16. Okay, so you check whether that 16 is already entered. So it is already entered, isn't it? So 5 is already visited. So no need of entering it again. So what we are going to do? We are going to delete this and we are printing. Meaning is it is being visited. Okay, so what are the elements I visited? So 10 is being visited and 15 is also visited. Okay, so now take the next front element is 16. So now the next front element is 16. Now you write the adjacent element of 16. Okay, so what is adjacent element of 16? So adjacent element of 16 is 8 and 9. See, the adjacent element of 16 is 8 and 9, isn't it? So now you see 8 is also visited. Okay, 8 is also visited. So no need to enter. Then 9. So 9 is not yet visited, isn't it? So what you should have to do? Enter this 9. Enter this 9 here. Right friends, are you all clear? So 9 is being added inside the queue. Okay, so now delete this 16 and you can just print it over here. Okay friends, 16 is being added. So now what is the next front element? So the next front element is 1. Okay, so the next front element is 1. You just find what are all adjacent elements that are present for 1. So the adjacent element that are present with that of 1 is 8 and 9. Okay, so 8 and 9. So 8 is also being visited. 9 is being entered inside the queue. Okay, see 8 is visited, isn't it? See, already visited. So 9 is already entered inside the queue data structure. Okay. Queue data structure is being inserted. So no more elements to be entered inside the queue. Okay, so what you are going to do? Just delete this element and you are adding it. 1. 1 is being added. So now find, is there any next, the next front element is 9. You are going to find any elements that are adjacent to 9. You just check. See, 1 is also visited, isn't it? So, is there any other element present inside the queue? All are visited. So, the element that is adjacent to 9 are 16 and 1. Okay, so element that is adjacent to 9 are 16 and 1. If you see the picture, 16 is also visited, 1 is also being traversed, that is it is being visited. There are no more elements present for to be traversed. So, stop for searching the element. Okay, you can stop for searching the element and you can print this also as your output, that is deleted from the queue and printed. Okay, so this will be your output. So you see the queue data structure will have no more elements, that is the queue will be empty. Suppose like this, if you are going to traverse each and every vertex in the graph, so by using a queue data structure, it is called as your breadth first search. So friends, suppose if you have any doubt in this type of solving, you please watch the video again and again until you are just clear with this concept of solving. Then only you will be able to solve any type of problem, right? So now in short, I will just give you the steps of solving this BFS algorithm. So another thing is that friends, for examination point of view, you needn't want to worry about the algorithm concepts, right? So you should have to know the steps of solving if this graph is given. You are going to find this output only. Okay, they will give you the list of options. So among that options, you are going to find which is having the correct traversal order. So in this diagram, in this case of a diagram, if I take 2 as an initial vertex, the order of solving is this: 2, 5, 8, 10, 15, 16, 1 and 9. Friends, I think so you will be having a clear idea of solving this. Okay friends, so now we are going to discuss about depth first search. Okay.